Hello guys, so today we are going to discuss about Minikube and why is it used for. So actually we know that Kubernetes is the most popular technology right now, so to manage the Docker containers. Yeah, but actually the Kubernetes deployment is not that much easy for everyone, so developer might feel very difficult to do this complete this Kubernetes setup. Test engineers might find it quite difficult, and a student might also feel it difficult, and they might not have the resources available to do the setup. And because Kubernetes being a cluster technology, at least it needs three VMs or three physical nodes. So to ease this, the Kubernetes engineers have developed Minikube, a software called Minikube. So what is Minikube actually? So Minikube it's just a just a software which can be installed in a single OS or like right now I have deployed it in my Ubuntu operating system, a single laptop, and I can play with Kubernetes, this Minikube. I can execute most of the commands of Kubernetes, and I can so I can understand the features provided by Kubernetes as well. I can deploy some applications as well here. So that's what we are going to do right now, how to deploy application. So let me first tell you, see, currently Minikube is running at my local laptop. This Minikube, this, if you see, status is running. So how do we run it? So this command, using this command we run Minikube start. So if you see, VM driver is KVM. So particularly why I have provided KVM, because I earlier because if you don't provide this VM driver KVM specifically, it is going to use VirtualBox. So VirtualBox is VirtualBox is one of the most popular, you can say, software using which you can deploy two or more operating systems in your existing operating system as guest. So so it's a virtualized software. So it's one of the KVM is one of the alternative. So in Ubuntu I faced some library issues with the VirtualBox, installing VirtualBox, and I was not successful running Minikube with VirtualBox. So I moved to KVM then, and KVM is working perfectly for me. So yes, so using this command we can run Minikube. So because it takes some time to start, around it will take 2 to 3 minutes. So I already started it. Yes, so Minikube status, if we see, this is running. So now so after doing this, what we do, we point our Docker registry to Minikube. So we will do this. So eval Minikube Docker. So now whatever Docker images we will create, that will be created within Minikube registry. Otherwise, if you don't provide this, it will be created within your default Docker repository. So images won't be visible to your Minikube. So to make sure that images are visible to Minikube, we provide this command. Yeah. If you see here, I need to execute this in other terminals as well. Yeah. Yes. And yes. Now if you see, if we see Docker images, available images we have. So we have available images here. These are provided by Minikube itself. Yeah, but this one is minimal Java. This one was created by me. So it is nothing. It's the simple JDK image. So what I'm going to do right now, I'm going to deploy an application. So I have one application at my end. This application it's a Spring Boot application, and it can be deployed to Docker. So same application we are going to deploy to Minikube as well. So if you see here, content. So let me show you the Docker file. So if you see here Docker file, so firstly it will install the it will create a new image from where Java would be the base image, and yes, it is adding the Spring Boot jar. So what I will do right now, I'm going to show you pom.xml. So it's a Spring Boot, as I said, it's a Spring Boot application, and what I have used here, I have used a Docker plugin to Docker plugin. So if you see here, this is the let me show you the Docker plugin. Yeah, this is the Docker plugin, com.spotify Docker Maven plugin, and the image name will be Docker image prefix and project artifact ID. So Docker project artifact ID, we already this is the artifact ID, Spring Simple Root this one, and Docker image is this. So image will be created with Spring Boot Docker example / simple Spring Boot Docker plugin. So yes, so now how to run this? Yeah, see, if you see cat, I have created a readme file where installation and deployment instructions are provided. If we can run it directly using mvn package docker build command, or we can also run it using this command, docker build normal docker command. So that is docker build, and we can provide some name to it. So let us try to run it with this command. Yeah, so yeah, and we saw that images were yeah, so let it run, and meanwhile we can see what codes we have right now. So if you see here, we have Minikube get ports is one command. So sorry, not Minikube get ports, sorry, yeah, kubectl. So actually what this kubectl does, it is also a binary which we need to download. So this binary provides the cell like commands for managing the Kubernetes. So yeah, so it provides many commands, like if you see yeah, if we see here, it provides us many commands available, like get command to get the details, and edit command to edit resources, and rollout to manage the deployment. So we will see few of the command right now. So let's say so we just created one image, it is already built. Let's see if we get something here. Okay, Docker images. Now we see that now we see that an image is created. Okay, for Spring Boot Docker image is created as we described in the example. So that example also I will provide the link in the comment section. So you can also go through this example as well. So what I am going to do now, after this example, so we know that we have a Docker image. We have Docker images. So now we need to run this Docker image using kubectl. So what kubectl will do, it will deploy this image as a deployment, as a pod to the existing Kubernetes, or you can say Minikube. So what we are going to do that right now. So how we are going to do that? This is we have a simple command here. Let me show you. If kubectl run, yeah, so we have this command here. So kubectl run. So what it will do, it will create a deployment. This is called deployment. So we are going to deploy this image. Okay, so we have to provide a deployment name and the image name. This is the image name. In which port it will be accessible? In 8080 port. And image pull policy, if not present, means we are not going to pull this. So now I am going to run this. Yes, deployment created. Now if you see, we have a pod ready. Yeah, this one. Okay, now if you also see, we have a deployment ready. So what does it mean? Like, we have a pod, we have a deployment. So actually we created a deployment. If you see, we created this deployment. So we actually create a deployment, and that deployment, it creates pod. So deployment, we can say deployment creates the pods. It manages the pods as well. So we can also, with the help of deployment, we can create multiple. We can scale the pods. We can increase the number of pods. We can decrease the number of pods. So that's. So actually we provide commands to deployments, and deployment creates the pods. So yeah. So if you see, right now it is desired, current, and to date available. So currently we have only one replica of this deployment. So it shows one, and this is the pod actually. So yeah. So we know deployment manages the pod. So but what pod is? So pod is something like it's an entity physical. It's an entity of multiple containers. It's an entity of multiple containers which do some functionality. Okay, so it is hosted in the same host. So we can say, in simple words, we can say that pod is the collection of multiple containers, one or more multiple containers, which are deployed in single host, and they provide a common functionality. So yes, this is pod. And what is deployment? Through deployment, we are creating the pods. Now we are done with this, and yeah. So now we have a very interesting part, like Minikube. We are going to see dashboard. If you see dashboard, so it will open up a dashboard for us. Okay, yeah. Meanwhile, we will also see, yeah. So if you see, dashboard is, yeah. So we have a dashboard here. Now if you see deployments, so we have a Spring Boot simple deployment, the deployment we created, and we have pods, the pod we created. Now in pods, what we can have multiple pods as well. We are going to do that soon. So let's go to this again. Yeah. So now as we have created a deployment, and that deployment is having an application. Okay. So now we need to test that application, how that application is accessible. So there is a command. We already get pods. Yeah. There is a command. So right now, see, there is only one service running. It's a Kubernetes service. So we have to create a service so that external world can see the application. So currently application, we saw that application, we created an application on 8080 port, that is container port, but this is not accessible to external world. So we have to create a service first. We will provide that service will provide a port, and that port will be accessible to external world. So how we are going, so now we have to create that external service. So now for this, we this kubectl, using kubectl, we have a expose command. So we are going to do that, kubectl expose. So yes, so this command we have. So kubectl, this will expose a service. This will expose deployment as a service. So we have to provide deployment and the name of the deployment. So see, pods are managed using deployment. So everywhere we have to provide the name of deployment. So yeah, so Spring Boot. So once we do this, yeah. So see, service Spring Boot expose. Now what we are going to do, this. Yes. So So now we see that simple Spring Boot simple is a service created on this port. Okay. Now this IP, you can say, you might be thinking that this IP we can this IP and port we can access it, but this IP is the cluster IP of the container. Again, it is not visible to the external world. So what we need to do, Minikube IP, we will do this. So this IP and this port is visible to the external world, this port. So what we will do, we will test it from here, cluster -v http 192.168.42.63:31410. Now if you see, yes, so we have an HTTP 200 response and hello world. What an output we got, hello world. Now let us check application, what is written in the application. Okay, so we will go to Java. If you see here, what we are doing, we are just once we hit this URL, it will straight away run this method, home method, and it will return the hello world. Okay, it will straight away return this string. So what this string has been written over. It's a simple Spring Boot example, REST based example, which we can use easily for testing. So this is it. And now, another thing I forgot to tell you that as we use Java plugin, as we use this Docker plugin, so for that we have to create a Docker folder within src main, and within Docker folder we have to keep the Docker file. So this Docker file is nothing. It's a simple plain Docker file which we use to put in our home repository. So Docker plugin reads this Docker file and then creates then automatically creates an image in the Docker registry. See here. So this is what we need to do in our example. I am going to provide this link as well. So now we know how to deploy an application. Now we know how to access that application. So let us again try to access that application. See. So again, so connect 200 we are getting, and hello world. So we have this. Now this is done. Now what we are going to do here, we went through what is ports, and we went through what is deployment, and now we will check scaling as well. So as I said that we can create multiple replicas as well. So let us create replicas. So currently we saw that number of ports are 1. Okay, here 11 says that only one replica is there. So let us now try to create replica. Okay. So this is the command of scale command. So as I already told you that kubectl provides the cell features. What's by cell feature? What I mean, it provides the commands using which we can manage. We can manage the Kubernetes. So kubectl scale, we are going to create 2 replicas. And what deployment again? So see, everything we are managing with deployment, not with ports. So we are providing Spring Boot simple. So yes, now we will do get ports running. So now we have 2 ports here. So can we see these 2 ports? Yes. Perfect. So and now we see the other thing we will see here is get deploy map. Now this is 2. So Spring Boot table, we have 2 instances, we have 2 ports here. So now in ports we see this 25, this is constant at both places. That means it belongs to it belongs to same deployment. And while this is this belongs to a this is specific or unique for each port. This is string. So let us check this in dashboard as well. So now we will see ports. Okay, yes, we have 2 ports here running, and number of deployments we have now ports too. So this is what I was going to show you, how these both things work. Now let us come here again. Okay, now what we did, like we created pods, we created services, we like once we create a deployment, pods are created. Now to make it visible to the external world, we create a service using expose command. Then we created multiple replicas using the scale command. Now what we are going to do, we are going to see a benefit of one of the major benefit of kubectl. We are going to destroy, or we are going to destroy one of the pods, and let's see how Kubernetes behave. So yes, so as we said that Kubernetes provides reliability and it provides scalability. So we are going to test this feature, how it provides that. So we are going to delete one of the pods. So let's say kubectl delete pods, and let's say we are going to delete this pod. Yes, delete it. Now let's see the output of this. Current pods terminating. We will see one is in terminating state, the one we deleted is in terminating state, and we have this in, we have one more that is new created. So what we understand from here is like Kubernetes itself managing the replicas, and itself is taking care of the scalability. So whenever a pod is destroyed, it will automatically create another pod, so that your only existing node or the remaining node doesn't is not loaded with all the requests, and even might that get down because of the extreme load. So it itself creating the another node, so that your environment is remains same. So that's the major benefit, I would say here. So yes, we saw, now if we see only 2 nodes are running, and get deployment is still 2. So see, now this number is changed, this unique ID is different. So now we saw scalability as well. Now what we are going to do, we are going to safely delete our deployment. See, if we see the service is still available. Hello world. So this is reliability, this is failover, and high availability. This is the advantage of Kubernetes, where there is zero downtime, and without in few minutes new pod is created by with the help of the deployment. So now what we are going to do, we are going to delete the deployment itself. Now kubectl and delete deployment. So we are going to delete deployment. So as we said that deployment is being pods are managed by deployment. So once we delete the deployment, it will delete the number of pods. No resource found. It will also delete the pods. So it's terminating. Now we see if we see this, okay, so running, and deployment is there. Currently we don't see any deployment. Let's see this again, pods, it's in terminating state. And what about services then? See, services actually, the port is still up. The port is still up. But the binding port, the 8080 port, which we mentioned while while running the image, while creating the deployment from the image, if you remember. So 8080 port we mentioned, that is down because we deleted the deployment. Let's see the output of deployment, this get ports again. So you see no resources found. Now, but service is still running. So we need to delete the service as well. Specifically, get services. So we will delete the services as well. ctl delete service. So we will delete this service as well. Now see, connection reset by the peer. Now the output is it will connection with you. So as we have deleted the service, that port 314010 is again released and is no more available for connection. So now if we see here, yeah, so we don't have any ports, we don't have any deployments. That's how we deleted the deployment safely. Now what we are going to do here is so almost we are done with this session. Now at last we will safely close the Minikube as well. Yeah, so that's all for the today. I hope this will help you in your in understanding Kubernetes and Minikube better. Thanks a lot for joining.